Hello. Ready to help with any questions or tasks you have in mind. What can I assist you with?
Do you do mathematics?
Indeed, I can handle a wide range of mathematical problems, from basic arithmetic to advanced calculus and beyond. Whether you need help solving equations, understanding geometric concepts, or working through complex algorithms, feel free to ask for assistance.
Can you do basic calculus?
Of course, I can assist with basic calculus. We can cover limits, derivatives, integrals, and more. What specific topic?
Integrate x squared over x squared plus 3.
Certainly. Let's integrate the function x squared over x squared plus 3. First, we can simplify the integrand, integral from 2 of x squared over x squared plus 3 dx. We can rewrite the integrand as follows: x squared over x squared plus 3 equals 1 minus 3 over x squared plus 3. So, the integral becomes integral from 2 of 1 minus 3 over x squared plus 3 dx. This can be split into two separate integrals, integral from 2 of 1 dx minus integral from 2 of 3 over x squared plus 3 dx. The first integral is straightforward, integral from 2 of 1 dx equals x. For the second
Stop.
integral,
And so on until it's got the answer. Hopefully you can see that down here at the bottom. X minus root 3 arctan x over root 3 plus c. And that looks right, but let's get it to check it. If we differentiate that, you get 1 minus 1 upon this squared times root 3. I think it's going to work out right. 1 over 1 plus x squared was 3. Okay, let's see. So I'll get them to differentiate it anyway. Can you check that by differentiating it, please?
certainly. Let's differentiate the result x minus square root of 3 arctangent x over square root of 3 plus e to verify that we obtain the original integrand x squared over x squared plus 3. We will differentiate each term separately. 1. The derivative of x is derivative with respect to x equals 1, 2. For the term minus square root of 3 arctangent x over square root of 3, we use the chain rule.
Okay, stop. Yeah, it certainly seems to
I didn't catch that. Could you please rephrase your question?
Seems to get it back to the beginning there. That looks perfectly okay. So you show how it shows how it can do that. Let's do something else. Find the roots of the polynomial x squared plus 3x plus 2.
Certainly. To find the roots of the polynomial x squared plus 3x plus 2, we need to solve the equation x squared plus 3x plus 2 equals 0. We can use the quadratic formula, which is given by x equals minus b plus or minus square root of b squared minus 4ac over 2am for the polynomial x squared plus 3x plus 2. The coefficients are equals 1, b equals 3, c equals 2. Substituting these values into the quadratic formula, we get x equals minus 3 plus 4.
It's got the answer, of course, minus 1 and minus 2. I just wonder if it can do something while I'm doing this live, if it can make up a matrix with that characteristic polynomial. Can you make up a matrix with that characteristic polynomial, please? It's very easy to do.
Certainly. Given the characteristic polynomial x squared plus 3x plus 2, we can construct a matrix whose eigenvalues are the roots of this polynomial. The roots of the polynomial are x equals minus 1 and x equals minus 2. A common way to form such a matrix is to use these roots as the eigenvalues of a diagonal matrix or to construct a companion matrix. Diagonal matrix, a simple diagonal matrix with the eigenvalues minus 1 and minus 2 would be parentheses matrix containing a equals minus 1, 0, 0, minus 2 companion matrix.
That looks like we would call that observable canonical form in control systems, and that's diagonal form And there's a third form which we call with the -3 and the -2 along the bottom row. We call that controllable canonical form. So I was quite surprised it actually did manage to do that. Quite interesting. Some other problems here, because I'm kind of doing this in the dark. It's a little bit difficult to do this. So I've got to get it to start camera. So there's the camera, so I know what I'm photographing. I'll put on a bit of light, and what's going to happen here is I'm going to photograph an equation, which is a differential equation, and then in the dark I'm going to put a light on it, and then that'll be analysed by the AI, which is the vision AI, and then I'm going to send that to the text AI, which is better at maths than the other one. So put the light on, and then I'll do this. What can you see?
I am a vision AI. I can see the following. A handwritten mathematical problem on a piece of paper. The problem reads, solve for vt followed by the differential equation t dvt slash dt plus vt equals ut, where ut equals 1 and v0 equals 0. The handwriting is in black ink, and the paper appears to be resting on a dark surface, possibly a keyboard. The equation and conditions are clearly written, and the paper shows some slight creases.
Okay, send that. And it should see that and act upon it, and try and solve that equation. It's a first order differential equation. It's probably out of the view of you at the moment, but I'll just try and move it along. It'll come into others.
Certainly. Let's analyze the given differential equation and solve for Vt. The differential equation provided is t dvt over dt plus vt equals ut, where ut equals 1 initial condition, v0 equals 0. This is a first-order linear non-homogeneous differential equation. We can solve it using the method of integrating factors. Step 1. Standard form. Rewrite the differential equation in standard form. dvt over dt plus 1 over t vt equals 1 over t ut. Since ut equals 1, dvt over dt plus 1 over t vt equals 1 over t. Step 2. Integrating factor. The integrating factor is given by mud equals e to the power of integral from 2 of 1 over t dt equals e to the power of t over t. Step 3. Multiply through by the integrating factor. Multiply both sides of the differential equation by e to the power of t over t, e to the power of t over t dvt over dt plus 1
Stop.
over t.
That'll drive me mad. So use the integrating factor method. No need to do that, but it's kind of a good way to do it. And because it knows the initial conditions are 0, because I put that on the piece of paper, it's come up with the final answer, which is put a wee box around it. So I hope you can see that. 1 minus e to the minus t upon t. And I just put that down because it's charging of a capacitor in an RC circuit. An exponential rise. Those of you that are electrical engineers will recognise that, and that shows you how to how it does mathematics. Of course, it can do far more complex things as well,
I didn't catch that. Could you please rephrase your question?
Show me what a Z transform is. Oh, it does.
Certainly. This transform is a mathematical tool used in digital signal processing and control theory to analyze discrete time signals and systems. It converts a time domain sequence into a complex frequency domain representation, which can be easier to manipulate mathematically. Definition of the Z transform. This transform of a discrete time signal xn is defined as xz equals sum from n equals 0 to infinity of xn z to the power of minus n, where xz is this transform of the sequence xn. Z is a complex variable. The series converges for certain values of Z properties and applications. 1. Linearity. This transform is linear.
Stop. Well, you can see how it's not very good at pausing in between phrases, but it describes there quite nicely the Z transform. Gives an example, Z over Z minus A. That was a simplest one of the sequence a to the power n, and it's quite good.